Hello everyone, this is Mr. McMillan, and I'm here today with the video that or what we did in class today, the examples on arc length, sector area, and angles and arcs in circles. So this is a combination of these three different topics here. And, in the previous video, we went over the problems or went over the different formulas for each one of those. And now we're going to talk about how to use those. We have done some examples before, but make sure that you watch this video as well, because this shows some additional examples for things you may not have seen before. So let's look at number one. A bicycle tire, as represented below, has 8 spokes that form congruent central angles. What is the degree measure of arc BKE? So the first thing is it wants to know the arc BKE. So you start at B, and the next letter you go to K. So you're going to go down to K. Okay, and then you go to E. So in red there, that arc is your degree, or what you're looking for the degree measure of. So you're looking for that arc. Now you may be going, well, we don't have any information here to help us find that. Well, the problem gives us one other key piece of information, and it's that the bicycle tire has 8 spokes that form congruent central angles. So you have 8 spokes here that form congruent central angles, which means that each one of these sections has to be exactly the same. They have to be identical, which means these arcs must be identical as well. So if we want to figure out what one piece is, we have to determine what our whole of the circle should be equal to. And the whole thing of a circle, the whole angle and arc degree measure, is equal to 360 degrees. So if the whole thing is 360 degrees and we're looking for one part out of 8, then what we're doing here is we need to take the whole thing and split it up into equal 8s. So that means that we take 360 divided by 8, which gives us 45 degrees. So that means that each section here is equal to 45 degrees. Well, we have one section 45, but then we have all these ones in red here. So each one of those is 45 degrees. Again, because they are congruent. Now we have 6 of them. They're each 45. So to figure out the measure of arc BKE, we must take 45 and add it together with itself 6 times, or we take 6 times 45, which gives us 270 degrees. All right, next up is number 2, and number 2 wants us to determine the measure of angle KLM. So we start at K, and unlike before where we were doing an arc, this time we're not going to be on the edge. We're going to be going inside, following the straight angles marks. So we go K to L to M. So it's this arc, or this angle, excuse me, right here at vertex L. Now the thing is, the middle vertex is always, or the middle letter rather, is always the vertex. Okay, so the middle letter of your angle is always the vertex. So the next thing is, since this is a circle and we're dealing with an angle in it, we need to determine what type of angle L is. And we do that by looking at where the vertex is. So the vertex is here at angle L, and that vertex is on the circle. And since the vertex is on the circle, we are dealing with an inscribed angle. Now, in order to determine the inscribed angle, we need to determine what its arc is equal to. Because the relationship between the inscribed angle and its arc is that the angle is equal to 1/2 of its arc. Now, to determine what arc that it intercepts, which one it belongs to, then you need to start with the first letter, and then you go immediately to the second letter, or the last letter, excuse me. So K to M is the arc that goes with X here. Okay. So how are we going to determine that arc? Well, we know that arc LK is 26, but we also know that LM is a diameter. And what does a diameter do to a circle? Well, a diameter cuts the circle into 2 equal pieces. And the 2 equal pieces of the circle would both have a degree measure of 180 degrees. So that means that we know this is 180, and we also know that this is 180. Well, if this is 180, and we know this is 26, to determine what Km is, we take 180 and subtract 26, which gives us 154. Now that we know that that arc is 154 degrees, we can use our formula angle equals half of the arc to figure out what X is. So we take 1/2 of 154, which is just 154 divided by 2, and we get that X would be 77 degrees. So the measure of angle KLM is 77 degrees. All right, number 3. Number 3 says, given circle X below, determine the value of X. Now X, the X it's talking about is right here. And there's important...
Marshall Boyd, if you're in the building, please report to the front office. Marshall Boyd.
So number 3, it's there's an important thing here that we notice, and that's that we have 2 triangles that share an intersection point. So they share that part there. Now, when you have this, you'll notice that Y, Z, W, and V are all on the circle, which means all of these angles are inscribed angles. Well, there's a theorem that states that any angle, any inscribed angle that shares an intercepted arc with another inscribed angle makes them congruent. So, for instance, what I'm talking about here, if we look at angle Y, okay, we look at angle Y, and we see that if we follow its angle here, we see that it intersects the arc VZ, right? So we see VZ there. Now, if we look at our W here, we see that the arc starts at its first angle side, and the Z ends where the second angle side does. So W is also part of that same arc, which means that W must be congruent to angle Y. So that means that angle Y must be equal to 29 degrees as well. Well, now we have a triangle here, and we have 2 angles in the triangle, and we want to find the third. So the sum of the angles in a triangle is 180 degrees. So that means that X plus 29 plus 75 must equal 180. So to find X, we take 180 minus 29 minus 75, and we get that X is equal to 76. All right, number 4, for the following, KM and KL, apologies for the lights. and KL are tangent to the given circle, and the measure of minor arc LM is 138 degrees. Find the value of X. So X here is here on this angle, and we want to determine what the value of that angle is. Well, we know that that vertex there lies outside the circle. So the vertex is outside. So what type of angle has a vertex that's outside the circle? Well, that would be an exterior angle. And in order to find an exterior angle, we need two different arcs. And an exterior angle follows the formula big minus small divided by 2. We take the big arc minus the small arc and divide it by 2. Well, in this case, if you look at the picture, do we have two arcs or do we only have one given to us? And you should see that the 138 is the small arc. We're given the small arc, but we're not given the big arc. So we need to determine what this big arc is. Now, if you'll notice, the big arc and the small arc put together equal the entire circle, which is 360. So our big arc, we have to take 360 and subtract 138. And when we do that, we get 222 for our big arc. So now we have our big arc and we have our small arcs. We just plug those in. So our big minus small is 222 minus 138. And then we divide by 2. 222 minus 138 gives you 84. 84 divided by 2 is 42. So our angle is 42 degrees, so X is equal to 42. All right, number 5. Number 5 says, what is the measure of angle 1 in the figure below? Now, we have to still determine what type of angle it is. And the vertex is inside the circle, which means that we're dealing with an interior angle. So since we're dealing with an interior angle, we still need to have two arcs. And those arcs must be opposite of the angle that we're trying to find. But if we look here, angle 1 is opposite of these two arcs, which have nothing labeled on them. So we're going to have to determine another angle first before we can find angle 1. So let's look here. We could determine this angle, and if we do that, we can find angle 1. And here's how. The interior angle follows the formula arc plus arc over 2. So for X, X gives you these arcs. Those are the arcs that you want to use. So you take 117 plus 141 and then divide it by 2. 117 plus 141 is 258. 258 divided by 2 is 129. So this angle here is 129. But notice that that's not what the question was asking us for. We just put that X in as a placeholder so we knew what we were looking for there. Instead, it wants us to find angle 1. Well, what do you notice about angle 1 and our 129 here? Well, you should see that angle 1 and X lie on the same line. So that means that since they lie on the same line, the sum of their measures is equal to 180. They're a linear pair. So to find the measure of angle 1, you take 180, subtract 129, and you get the measure of angle 1 is 51 degrees. All right, number 6. Number 6, the figure below shows a circle. Given that the measure of angle DEF equals 64 degrees and the measure of angle EFD equals 71 degrees, what is the measure of arc FE? So we're looking for arc FE. I'm going to highlight it here in red. So we're looking for that arc there. So in the problem, it also gives us that we have a 71-degree angle and a 64-degree angle. And there are a couple different ways that you can do this problem. The first is that you know that you have a triangle DFE here, okay? And you already have two angles in that triangle. So if you want to determine what angle or what your angle D is, you know that they have to add up to 180. So the measure of angle D has to be equal to 180 minus 71 minus 64. And when you find the measure of D, you get that it's 45 degrees. So angle D is 45 degrees. Now look at angle D. What do you notice about its vertex? Where does the vertex lie? Well, the vertex lies on the circle. So that means angle D is an inscribed angle. And since it's an inscribed angle, there's a relationship it has with the arc. We've already talked about this. The angle is 1/2 the arc if it's inscribed. But this time we're looking for the arc instead of the angle. So if the angle is 1/2 of what the arc is, then the arc must be twice what the angle is. So your arc is FE. Your angle is 45 degrees. You multiply it by 2, and you get that the measure of arc FE is 90 degrees. There was another way that you could do that. You could also say that this arc would be twice of what 64 is, so that would be 128. And this arc would be twice of what 71 is, which is 142. Then you could take 360 and subtract 128 and 142 to give you 90 as well. Either way is valid. Okay. All right. So let's move on to number 7. Number 7 is going to be the last of the types of angles problems. So in number 7, it says, given the measure of angle NMP is 31 degrees, so NMP is right here, and it's an angle, so it goes inside the circle. And the measure of arc QP is 95 degrees. What is the degree measure of arc NKQ? So I'm going to highlight the arc that we want to find. Arc N, then we go to K, and then we go to Q. And that's pretty terrible, but it's okay. Now, how are we going to find arc NKQ with what we know here? Well, we know that this is a 31-degree angle, okay? And specifically, this type of angle is a central angle. And a central angle is always the same as its arc. So we know that the arc NP must equal 31. And we already know what this arc is. It's 95. And if you'll notice, this arc, and this arc are the only 3 arcs in the problem. So what that means is we can use their measures to determine what the degree measure of this arc should be. So what do the arcs all add up to in a circle? It adds up to 360. So NKQ would have to be equal to 360 minus 95 minus 31. And if you take that 360 minus 95 minus 31, you get that arc NKQ is equal to 234 degrees. Okay. So those are the types of angles that you can find in many problems that we do. Now let's shift gears back to what we did before that and talk about arc length and sector area. So on number 8, it says Robert's circular porch has a section as shown below. What is the area of this section of the porch to the nearest whole number? So we're looking for a sector area. We're looking for sector area. And there's two things that we need to know for sector area. The first is our radius, and the second is our angle or our theta that we're going to use to determine what the sector area is. So in this case, your radius r is given to you as 16 feet, and your angle theta is given to you as 105 degrees. Now, when you're trying to find sector area, it's a fraction of the circle's area. And that fraction has to deal with this theta, okay? Now, a whole circle would be 360 degrees, but we only know the part of 105 degrees. So our fraction is going to be theta over 360, because this is our part over the whole thing. Then, since we're doing the area of a circle is given to us as pi r squared. So we're going to multiply theta over 360 by pi r squared. So plugging our pieces in here, we get 105 over 360 times pi times 16 squared. And it wants us to approximate this to the nearest whole number. So when we go into our calculator, Desmos or whatever else you're using, let me clear all this away. Whenever you do that, you get divide 105 by 360, and then times pi, and then times 16 squared. And you get that your area is approximately equal to 234.57, but it wanted it rounded to the nearest whole number, which is 235. So your area there is 235. Next up, number 9, John wants to divide a pizza into 12 equal pieces. The pizza has a radius of 13 inches. What is the exact area of each slice? Now, John wants to divide this whole pizza into 12 equal pieces, and we want to know the area of each slice. Well, this pizza has a radius of 13 inches, and we know we're looking for sector area, so we're going to do our area equals theta over 360 times pi r squared. But here's where the fraction gets a little bit tricky. This is your part over your whole thing, but that's talking about angles. In this case, John says that he's dividing a pizza into 12 equal pieces. So the whole thing has been cut into 12 pieces. So that's your whole. And you want to find the exact area of each slice. So if I give each person in this room a paper, how many papers did I give to each person? I gave 1 per person, right? So that means that the piece is 1 over 12. So that's our fraction, and then we finish it off by pi r squared. So pi times 13 squared. So your area, 1/12 pi r squared, and it wants the exact area. So in your calculator, you're going to remove the pi, and you're just going to type in 1 over 12 times 13 squared. Okay? And you're going to notice that it'll give you this decimal. If you click this circle and simplify it into a fraction, you get your area as 169 over 12. But you have to make sure, since it's an exact area, that you put the pi after it. So your exact area is 169 over 12 pi. All right, number 10. Number 10 says circle Q has a diameter of 24 feet. Sector RQS of circle Q has a central angle of 45 degrees. What is the approximate area of sector RQS? So I'm going to draw a circle. And it says circle Q here. And you have RQS here. with a 45-degree central angle, and your diameter is equal to 24 feet. So we're looking for the sector area. So we need two pieces of information. We need our angle theta and our radius r. Well, in this case, it gives us a diameter. So how do we find the radius when given the diameter? Well, the radius is always half the length of the diameter. So your radius is going to be 24 divided by 2, which is 12 feet. Your theta is 45 degrees. And your formula for sector area is theta over 360 times pi r squared. So theta is 45 over 360. Then you have pi times 12 squared. And it wants the approximate area, so you can just throw everything into the calculator. So we put 45 divided by 360 times pi times 12 squared. And so we get our approximate area is 56.5 when rounded to the nearest tenth. Okay. All right, number 11, the circumference of circle A is 126 pi. What is the length of RKT? Now I want to point out something here. You'll notice it says length and not degree measure. So whenever it says length, you're looking for arc length if it's talking about an arc. So you're looking for the length of RKT, so this arc here. Now, just like sector area, we need to find our theta and our radius. But in this case, we don't really need the radius, and I'll explain why. Your formula for arc length is length equals theta over 360 times 2 pi r. And 2 pi r in your circle is known as the circumference. So in this case, what is your theta? Well, theta should be equal to 148. And you put it over 360. Now we don't know our radius because all it gives us is the circumference. Well, 2 pi r is our circumference. So that means that 2 pi r is equal to 126 pi. So we can just throw that right in there. So now we go in and we can type in, I'm going to do this one exact, so 148 over 360 times 126. So the length is equal to 51.8 pi. And if you typed in pi after it, you would get that your length is approximately 162.7 units long. So let's look at number 12. Circle T has a diameter of 22 inches and the measure of angle QTR is 60 degrees. So I'm going to go ahead and put that in there. What is the approximate length of QR, of arc QR? So we're looking for arc length. So we need our theta and we need our radius. Well, our theta is easy. It's given to us as 60 degrees. But in this case, you'll notice that we're given a diameter of 22 inches. So since we're given a diameter of 22 inches, to figure out our radius, we take 22 divided by 2, and we get 11. So our arc length formula is theta over 360 times 2 pi r. So that means we're going to have 60 over 360 times 2 times pi times 11. And it wants the approximate length, so you can just plug all that into the calculator. So we're going to do that right now. And you get 60 over 360 times 2 pi times 11. And your approximate area rounded to the nearest tenth, or sorry, approximate arc length would be 11.5. All right, last four. Number 13. Number 13 says circle R is shown where the measure of angle SRQ is 120 degrees and radius RS equals 8 inches. What is the area of sector QRS? So we're looking for sector area. So our sector area, we need theta, which is 120, and we need our radius, which is 8. So our area is given to us by theta over 360 times pi r squared. So your area would be 120 over 360 times pi times 64 squared. Or sorry, not 64 squared, excuse me, 8 squared. 8 squared is 64. I was getting ahead of myself. So plugging that in, we get 120 over 360 times 8 squared, because I'm going to leave the pi in there. And we get that our fraction is 64 over 3. And then we put a pi. And if you did this approximately, then it would be 67.0 inches squared. So our exact area is 64 over 3 pi. Number 14. Number 14 says to find the length of arc XWZ. So XWZ here is this arc highlighted in red. And you want to find the length, not the degree measure. Given the diameter of circle Y is 16 kilometers. So we're looking for arc length here. And since we're looking for arc length, we need to know theta and we need to know our radius. Well, in order to determine theta, we see that this arc here is 84 degrees, which is our minor arc. But we want to determine what the major arc is. And you'll notice that when we put those two arcs together, it makes the whole circle. So our theta is going to be 360 minus 84, which is 276. And our radius, well, we're given a diameter of 16 kilometers. So that means our radius has to be 16 over 2, which is 8. So the length, our arc length is given to us by theta over 360 times 2 pi r. So in this case, it's going to be 276 over 360 times 2 pi times 8. And then we just go and plug that into the calculator. So 276 over 360 times 2 times 8 would give us a fraction of 184 over 15, and then we tack on the pi. If you do it approximate, you would end up with 38.5. I'm going to do it exact. So it's 184 pi over 15. All right, number 15. Number 15 says the minute hand on a clock is 15 inches long and travels through an arc of 150 degrees every 25 minutes. What is the length of the arc the minute hand travels during this 25-minute period? Round to the nearest tenth. So we're looking for arc length, which means that we need to know our theta and our radius. Well, it tells us that the minute hand on a clock is 15 inches long. And a clock, the minute hand starts at the center. So that means that our radius would be 15 inches. Then it says it travels through an arc of 150 degrees, which is what our theta is. And now we just plug it in the formula. So we have length equals theta over 360 times 2 pi r. So we have 150 over 360 times 2 pi times 15. And if we want it rounded, so we're just going to plug everything in here. So 150 over 360 times 2 pi times 15. And rounded to the nearest tenth, we get the length of this is approximately 39.3 inches. And finally, number 16. Number 16 says the diameter of circle A is 18 centimeters long, and the measure of angle BCD is 40 degrees. What is the length of BD? Now, here's the important thing here. Look here at angle C. This is an inscribed angle, so we can't just say theta is 40 degrees. We actually have to determine what our central angle would be based on that. And we know that the arc would be equal to twice what the angle is, so our arc would be 80 degrees. So theta is going to be 80 degrees. R is going to be half of 18 because it's our diameter, and we get 9. And it wants to know the length of the arc. So the length of the arc is given to you by theta over 360 times 2 pi r. So theta is 80 over 360. Then we have 2 pi times 9. And now we just plug it into the calculator. I'm going to do it exact. So 80 over 360 times 2 times 9 will give you 4, and then you tack on the pi at the end. But if you did it approximate, it would be 12.6. So your exact length here is 4 pi. Okay. And that's going to do it for this video, guys. I hope this video helps with some of the problems on the other worksheet that we've been working on. Continue working on that worksheet today and tomorrow. And we'll go over it in class in a couple days. So thanks, guys, and I will see you in the next video. Please make sure that you email me or let me know if you have any help. You can stay after, or you know, we can schedule a Zoom time to help you out. Thanks.